In this video, we'll talk about how to download your data and then analyze it in SPSS. So first you want to go to your Qualtrics account and go ahead and log in. And then locate your survey with the data. So in this case, it's glasses study. And once you have your survey up, go ahead and click View Results, and then Download Data. And you're going to want to download it as an SPSS file right here. So it'll take a moment to load, and it'll ask you if you want to download the file. And it'll originally be a zip file, so you want to open it with the archive utility. So you can click OK. And this will automatically upload it right here onto your desktop or wherever you download files. I already have a copy of it open, where I've tweaked it a little bit so we can analyze data. But here are the original variables that were of importance to us. Let me go ahead and show you this in variable view. So the first one, participant, I agree to participate. We had no and yes. And for everybody that I'm including, or all the people that said yes. And then if they said yes, they saw one of the pictures, either men with or without glasses, or women with or without glasses, and they gave an attractiveness rating on a scale of 1 to 10. So everywhere where you see dots are missing data. So for this person, they only got female 1, no glasses, and they gave her a rating of 5. For the next person, she got female, no glasses, but it was the second female, she also gave her a 5. And I've ordered this a bit so that it's all the women first, in the no glasses condition and then glasses condition, and then all the men in the no glasses and glasses conditions. Then they answered some demographic questions about themselves, such as their gender, their age, and their race. And it looked like everybody fit into a racial category except for one person who put in Indian. Now, if you wanted to, you could say, well, I believe that that's Middle Eastern, or probably you should just say, well, we'll just keep them as other. So then I created some variables in order to clean up this data here and make it easier to access and analyze. One of them was target gender, the gender of the photograph target, which of course was either female or male. And the other one was target glasses, whether the photograph target wore glasses or didn't. And here I did no glasses or glasses. And then the target's attractiveness rating, which I just copied from their survey responses, but then I ordered it according to the target gender and target glasses. So when you analyze your data, you're going to be running an ANOVA, and that's because you're going to have 2 independent variables and 1 dependent variable. And I'll go ahead and shrink this down just to see the variables that we're interested in. So in the end, you should have 2 independent variables with 2 levels each. In this case, mine's the target's gender, whether it's female or male. And the other one is whether the target is wearing glasses or not. And then you should have 1 dependent variable that's continuous. In this case, what the attractiveness rating was given to each target. So whereas this was my original data right here, you'll probably have to do some kind of recoding, and it'll be different for each group, but in order to get it to just your 3 variables that you can run your analysis on. Again, 2 with 2 levels each, and then 1 continuous variable. So once you have your data, go to Analyze, General Linear Model, and Univariate. That's how you run an ANOVA. Now you're going to put your dependent variable in the dependent variable box. And here, that's the last one, how attractive is the person, is the target. And then you're going to put your 2 independent variables in the fixed factors box. For me, that's the gender of the photograph target and whether the photograph target was wearing glasses or not. And then you're going to do a few little things in here. One is you'll do a plots, which is a line graph. And you can just pop one variable into the horizontal axis and the other variable into the separate lines and click Add. And I like to do the other version just in case. So in this case, I'm going to switch which one's the horizontal axis and the separate line, and also hit Add. This is going to give you the same thing, but it'll look slightly different, and then you can choose which graph makes the most sense to you. So click Continue. And then the last one, go to Options and put in Descriptive Statistics. You'll need this for the means and standard deviations for each group. And click Continue. And that's it. Click OK and we'll take a look at the results. So usually what I like to do is scan down first to see the between subject effects to see if anything is significant. And it looks like we do have some significant results. So in this case, we had a total of 58 participants. And if we scan over to the SIG side, we can see that the target's gender, whether or not the target photographed person was female or male, had no significant effect on their attractiveness. In this case, P is greater than 0.05, so it's not significant. However, whether or not the target was wearing glasses, well, it did have a significant effect. We don't yet know if it was those who wore glasses were higher in attractiveness or lower in attractiveness, but there was a difference there. And then lastly, there was an interaction between whether or not they were male or female and whether they wore glasses on attraction. But we'll tackle these significant results one at a time. Let's go ahead and practice writing this up in a Microsoft Word document. So first you just want to say what your design was. You say something like a 2 by 2 experimental design was assessed using a factorial ANOVA. And once you have that set up, you can get into whatever effects you have. So you could say it was found that targets who wore glasses were seen as, and then we don't know if they're more or less attractive than those without glasses. So here we're going to go ahead and check the means. So in this case, we're interested in people who wore glasses versus those who didn't wear glasses. And in this case, we can see that in the no glasses condition, they had a mean attractiveness score of about 5, and in the glasses condition, they had a mean attractiveness score of 3.67, which is lower. So now we know that people who wore glasses had significantly lower attraction ratings than those who didn't wear glasses. So we could say as significantly less attractive than those who didn't wear glasses. And so now we just stated what that difference is and that it's significant. So it was found that targets who wore glasses were seen as significantly less attractive than those who didn't. And now we're going to put in some of these statistics. So the first thing we want to do is put in the means and the standard deviations of these two groups. So we could say it's found that those who wore glasses were seen as less attractive. Put in the mean of those who wore glasses right there. They had a mean of 3.67. I'm getting that right over here. And a standard deviation of 1.85. And you always want to round up or down from the 100th place. And then we're comparing that group to those who didn't wear glasses. And we'll give that the mean that it has, which is a 5.00. And even though it ends in 00, you have to report that because you always want to round to the 100th place. And a standard deviation of 1.70. And so now we want to give the inferential statistics, which in this case is an F statistic from the ANOVA. So since we ran ANOVA, we're going to put in a capital F. And then there are 2 degrees of freedom here. One of the degrees of freedom is for the variable itself. And so in this case, they're glasses, so we're going to use this row, and right here is the degrees of freedom for wearing glasses. So we'll put in a 1 there, and you put in a comma, space, and then the second number is always the df of error. So here the degrees of freedom for the error is 54. Then go space, equal sign space, and put in the actual F value for that item. In this case, again, go back to this row for glasses, and the F value is 8.90. And it's very significant. P is even less than 0.01. Now, if this was 0.01 or even 0.005, it would round to 0.01, you could put in P equals 0.01, but in this case, it's even less than that. So you can just change this to a less sign because you can't go any lower than 0.01 and still have it in AP formatting, because again, you have to keep it to the 100th decibel. So in this case, here's our entire sentence for that first main effect. It was found that the target who wore glasses were seen as significantly less attractive with their mean and standard deviation than those who didn't with their mean and standard deviation and all the inferential statistics. And just because we're going to eventually make a graph for this, we'll put that as a figure, so we can also put in figure 1 right here to remind ourselves to do that later. One other thing for formatting is you have to make sure to italicize all the statistical acronyms. So we'll do that by highlighting it and hitting Control or Command I to italicize it. So any single letter that stands for statistic needs to be italicized. So that's one down. So most of the time, you're not going to report on findings that are non-significant. For this class, since I want you guys getting practice of reporting findings, we'll report them even if they are non-significant. So in this case, we'll write down, it was also, let's say, it was found that there was no significant difference in attractiveness between female targets and male targets. But we still want to put in the means and standard deviations for these groups. So here we'll put in the mean of women and standard deviation of women. I'll put that as a placeholder. And then the same thing for men. So finding the means and standard deviations for these groups, we have to find it in this graph. In this case for women, it says female here. And we don't want it female just with no glasses or with glasses. We want female total, all the women together. And their mean was a 4.0. So right here, we'll put in 4.00. And their standard deviation was 1.91. And I got that just by looking at the side here. And then for male targets, their mean was 4.62. And their standard deviation was 1.84. And you can see that there is some difference there, but it's not enough to be significant. And just like we did before, we'll put in all the inferential statistics. And one thing is that when you're doing a 2x2 experiment, the DF is going to be the same for all of the results. But in case you want to double check, you can find again that for gender, the DF is also 1. And of course for error, it's still 54. In this case, the F statistic, which you can find in this row for target gender, is 1.72. And P is equal to, if you rounded it, 0.20. So P equals 0.20. And we'll also include another figure for this too, because we'll be doing figures for all of our findings, even if they're non-significant. Lastly, we want to put in our interaction. So you say, lastly, it was found that there was a significant interaction between these two variables on attractiveness. And so in this case, we already said what the two variables are, so we don't need to be redundant and say it again. But let's go ahead and put in the F statistics. And for interactions, we don't need to put in any means or standard deviations because we're not comparing main effect groups. So in this case, again, we'll put in an F. The DF is the same, 1, 54, because the DF for the interaction, target gender times gender glasses, or target times target glasses, is still 1. The F statistic in this case is 5.15, and the p-value is equal to 0.03. We're also going to put in a figure here through as well. So interactions, you also want to describe, in essence, what it looks like, and there's no right or wrong way to do this, as long as you're describing accurately. So for this, the best thing to do is scroll down to these plots and kind of figure out what it looks like. So with this one, we have two different versions of this plot. It's the same information. Let's actually take a look at this one. One thing I like is that the individual targets, female and male, are the two lines on each side, are glasses or no glasses. I mean, here it's just flipped, but I think this makes more sense to me. So it looks like for men, there wasn't that much of a difference between whether they didn't wear glasses or did wear glasses. A little bit less when they wore glasses, but it's a difference of like 0.1 or 0.2 points on a 10-point scale. That's pretty negligible. Whereas for women, it's a very sharp contrast between those who didn't wear glasses and those who did. A whole, well, about 2.5 point difference on a 10-point scale. That's much, much larger. And also, even the women who didn't wear glasses were about the same as the guys who didn't wear glasses, here only about a half-point difference at most. So it seems like the real outlier here is the women who wore glasses. So in this case, a group is really sticking out. It's the women who wore glasses. So that you can say, that's a sort of a simple way of putting it, but that conveys it to the reader. You could say, with women who wore glasses being rated much lower in attractiveness than all other groups. And there are many different ways to say this, but that's just one that makes sense to me. You could also say, just as another way of putting it, with the lowest attractiveness ratings among the women who wore glasses, or you could say, just to give you another example, with glasses having a negative impact on the attractiveness of female targets, but not of male targets. So any of these is totally a fine way of putting it. You just have to figure out which way makes sense for you and for your readers. So anyway, here's the entire paragraph with a couple of extra ways that you could have put it. Now we have to make these figures. Now figure 3 is already provided for us because that's this line graph right here. We just need to clean it up a little bit. So let's go ahead and lay these out on separate pages. An easy way to make a separate page is to hit Control Enter on Windows or Command Shift Enter on a Mac. And we'll just label this figure 1, make another page, figure 2, make another page, figure 3, because they all need to be on their own page anyway. So since we already have the line graph, let's go ahead and do this one first actually, and then we'll do the other two. So we're going to give the figure 3, and right here we'll say what it is. It'll be interaction between target gender and whether or not target was wearing glasses on perceived attractiveness. And again, there are many different ways to say that. I'm just trying to say that it was an interaction between these two variables on this dependent variable. And then also, according to APA, you have to italicize figure 3. There we go. So then we're going to put this graph actually on top of this. It'll go right here. But first, let's make this look a little bit better. So if you double click, you'll enter the chart editor program. And whatever you click on over here, you can change. So for example, one good thing is let's get rid of this gray background. So let's make the background white to really make those lines stand out. Let's also make the lines themselves bigger. So if you click on the lines, it'll select those. Let's give them a weight of 3. And if you click on any individual line, it'll then select just that one line. So let's select the male line, and let's make that line dotted. That way, even if this is printed in black and white, readers will still be able to tell the difference between the two lines. Well, let's make some of this text a little bit bigger because some of this is pretty small. You can do this by just selecting on every text element, and let's make it all 12-point font because that's what papers are usually written in. There we go. Now let's see. We don't really need a title to this graph. So if you want to get rid of text, select it once, and then click on it again. You'll enter editing mode. Let's just click on all this or select all this and hit delete. Get rid of it. There we go. And then let's go ahead and see if these titles work. So gender of photograph target, female, male, that all looks good. Photograph target with or without glasses, that looks fine. This one, estimated marginal means, doesn't really mean much. This should be average attractiveness. So let's go ahead and change that too. So click on it once, and click on it again, enters editing mode. And let's put in average attractiveness. Oops, there we go. And we'll put in scale 1 through 10 to remind ourselves what that scale was. Go and click off, and it should save it all that. And one thing I like to do just to make graphs very honest with what scale they're on is to make the whole scale available on the graph. So usually SPSS will zoom in on the lines, but let's go ahead and make it so that this scale goes all the way from 1 to a max of 10 on this graph. So if you click on the numbers here, and then you go over to Properties, click on Scale, and just make the minimum and maximum, the actual minimum and maximum of the scale that you're using. In this case, the scale had a minimum of 1 to 10. And then click Apply. There. I find that's a more honest way of looking at it, because you can see that there's not huge differences between the groups, but there is a sizable difference between this group, females with glasses, and all the other groups, and that none of them got really, really high rates of attractiveness, more like moderate to semi-low. So that looks good to me. So I'll go ahead and say close out and then close this, and it'll save all your changes into your output window. So once you have that, you can right-click and go Copy Special, and just make sure that Image is selected. The rest of these can or can't be selected, that doesn't matter, just as long as Image is selected. And click OK. And then go to your Word document, right-click, and hit Paste Special, and then make sure Picture is selected, and click OK. There we go. So you can also edit a little bit on here if you want to. Like for example, you probably don't want a black border around it. So if you click on this, you'll get Format Picture, and then somewhere in here you're going to get Crop. There it is. And you can crop out any element you don't need. Like all this empty space and these black bars. There we go. And that'll even allow us to make this a little bit bigger and still be within the page. So there we have our first graph and figure. Now for these other ones, figure 2 and 3, these have to do with main effects. And what I mean by that are differences between two groups. So the first one that was significant was between those who wore glasses and those who didn't wear glasses. So in this case, we want to make it a bar graph because a bar graph is an easier and better way to display main effects. So go to Graphs, Legacy Dialog, and Bar. And we're just going to keep it simple, keep everything on default settings. And so right here, let me go ahead and widen this out a little bit. What we're going to do first is click Other Statistic Mean, because we want our bars to represent the mean of the dependent variable, which in this case is how attractive the person is. So we'll put the DV, dependent variable, in the variable box. And then we'll put the IV we're interested in the category axis box. And in this case, that's going to be whether or not the photograph target wore glasses. And the last thing we want to do is put on error bars. So click Options, Display Error Bars, and Continue. So now that we have our bar graph set up, go ahead and click OK. And right here you can see it looks good. So in fact, those without glasses were seen as more attractive than those with glasses. And the fact that these error bars don't really overlap shows that it is a significant difference. Although sometimes the error bars will overlap even if it's significant, that's fine. That just means that the equation used to make these error bars is a little off for what we're doing. The error bars are just a good way of showing the amount of variability within each group. So again, let's go ahead and edit this graph a little bit. So I'm going to make the background white, make it pop out. I like to make each bar a different color. So we can make the no glasses group maybe blue, and the glasses group red. And then again, we just want to make all the text legible. So a 12-point font. And then this error bar is 95% confidence intervals. We don't need that text. So we can just select it and delete it. And then let's see. This one, I don't like the way how long this title is, so I'll change this again to Average Attractiveness, Scale 1 through 10. And then again, I'll change this to the actual scale of our survey, which is a 1 to 10 scale. And there you go. That's a more honest look at what our data actually looks like. And one thing we can do, since we have spent all this work making this chart template look just the way we like, is we can save it by going File, Save Chart Template, and then just click All Settings, except that the axis is going to be a little bit different. So we'll uncheck text content because we'll be making with a different graph, but everything else can remain the same. And click Continue and just save that wherever. I'll save it on the desktop. Put it in Bar Graph Template. And click Save. So there we go. Now this is for figure 1, which was the significant difference. So we'll give it a little name. We'll say difference in attractiveness between targets who wore glasses and targets who didn't wear glasses. And again, we want to italicize where it says figure 1. And since we already copy specialed it and we figured out it as do image, you can actually just do copy in the future if you want to. But always do paste special so you can make sure image or picture is selected. And then again, we'll go ahead and crop out those lines in any sort of blank spaces. And then the last one is if gender had any effect, which it didn't, there wasn't any difference between gender, but we're going to want to put that in there anyway. So just remind us, we'll go differences in attractiveness between female and male targets. That's the last graph we need to do. Italicize figure 2. In this case, since we just made a bar graph, we could just go to the recall recently used dialog boxes, define simple bar, and then we're still doing the variable how attractive the person is under variable. We're just changing the category axis. In this case, we're kicking out whether the photograph targets were with or without glasses and putting in the gender of the photograph target. And here's where we can add that template is by going use chart specifications from, and then just locate that template file that we just made. Of course, we could do all the editing over again, but this is just a little bit of a shortcut. And let's make sure that the error bars are still there. Yep. And now click OK. And this one should look, well, not exactly like it, but it still has more formatting done to it than the last one. So we'll go and finish that up just by making these the right colors that we want. So we did, let's see, before, I think we did blue and red. Doesn't really matter what colors you use, but I like to be consistent. We got rid of where it said error bars, and we just changed this to average attractiveness scale 1 through 10. And we have the scale right, it goes from 1 to 10, so that formatted correctly. So see, it didn't take as long to do all the formatting with this one. So we'll just go copy, and then over here, paste special, select picture, and click OK. So there you go. That's how you can put in all of the graphs and, of course, all the other statistics in your results section. The thing that'll be quite a bit different from between each group is how you format the data so that you have your 2 independent variables with 2 levels each and your dependent variable. And of course, that's something I'll help you out with individually. But once you have that, doing the actual analysis is pretty easy and straightforward. And you'll end up with descriptions of 2 main effects, whether or not they're significant depends on your data, and interaction. And if you have a significant interaction, go ahead and include some kind of statement describing that interaction. If this wasn't significant, it would just say, lastly, it's found that there was no significant interaction between the 2 variables, and then you wouldn't need anything after that. But regardless, you'll also have the 3 graphs, one for the main effect of the first variable, one for the main effect of the second variable, and then a line graph for your interaction, each with a figure. So there you have it.